Okay, and I'm going to share my screen. All right. Hey, everybody. Thanks for joining us today. The purpose of this meeting is to provide you with an introduction to CUAHSI and the opportunities that might be of interest to you. Also, we wanted to give everybody a chance to meet some CUAHSI staff and connect some names and faces, as we hope you would consider joining CUAHSI events, taking advantage of our funding opportunities, and maybe even publishing your data with CUAHSI. So you've received many email messages from me over the past couple months, and as most of you know, I'm the Deputy Director of CUAHSI, and I've been with CUAHSI for about a year now. I oversee our education and outreach activities, and I'm the lead staff person for our DEI initiatives. I'm happy to be joined today by Julia Masterman, our education and outreach specialist, who is waving right now, and Tony Castronova, who is our senior research hydrologist, who might wave. So Julia will be speaking with you about our Summer Institute, and Tony's going to be speaking with you about our data and technical services. I also want to introduce you to Veronica Souza Gonzalez, who is our new education program manager. And there she is. She is the behind the scenes CVU administrator. So anytime there's a class change or a roster switch around, she's the one that's doing that. And she will be overseeing our grants program. So if you are considering applying for a grant, she is probably the one you will be working with on that. I will be spending my time today giving you an overview about some of CUAHSI's educational services and programming that might be of interest to you, and then drawing your attention to a couple of our grants programs that we're currently accepting applications for. And we're going to be happy to answer any questions that you may have. All right. So CUAHSI is the Consortium of Universities for the Advancement of Hydrologic Science Incorporated, which is quite a mouthful. And when I first started working for CUAHSI, I had to practice that pretty regularly to make sure I could say it right. But as consortium implies, we are a membership organization. However, most of our services and programming are open to anyone. Our membership fees are small and only serve to help offset some discretionary expenses that may not be allowed by our funding organizations. Our key financial support comes from the organizations listed on this slide, and they include the Department of Homeland Security, the Johnson Family Foundation, NASA, NOAA, and the National Science Foundation. Our mission is to shape the future of water science by strengthening interdisciplinary collaboration in the water science community, empowering the community by providing critical infrastructure, and this most notably is our cyber infrastructure. So we have 2 data repositories, and we develop tools for retrieval, storage, sharing, analysis, and visualization of data. And Tony will be speaking more about that in a few minutes. And we also promote education in the water sciences at all levels. And while we say that we promote education at all levels, a lot of our programming traditionally has been aimed at graduate students, postdocs, and early career faculty. So we all hope that all of you graduate students who participate in CUAHSI CVU ultimately become active members of CUAHSI and evangelists when you become water science professionals. To give you a quick overview of CUAHSI by the numbers, we were incorporated 20 years ago. So this year we're celebrating our 20th anniversary. We have over 120 member organizations. And for the past 20 years, it was universities with graduate programs and something related to the water sciences that were eligible for full membership. We also have affiliate and international membership status. However, this has changed recently, and we now welcome primarily undergraduate institutions with some focus in the water sciences for full membership. So despite the fact that we're a consortium with different membership tiers, all of our programs and services are open to anyone. And we've been starting to look at demographics of participants in our programs. And while we are a US-based organization, I can say with confidence that we have a global reach, as evidenced by students in CVU who are from Zurich. I also will say that we are a community-driven organization. Our community members are engaged in many ways, such as serving on our board of directors, our standing committees. They volunteer to teach in CVU or lead training workshops. And our community members are committed to our organization and our mission. So we value your input and ideas as CVU students. The other points on this are pretty self-explanatory, but they give you an idea of our governance, our staffing, and our reach. So we're relatively small, but we have a pretty big reach. We've gone up in Twitter followers over the past couple months, and if you're on Twitter, go ahead and follow us as well so you can find out about what we're doing. I also want to note that we are the hub for the Critical Zone Collaborative Network, and that's pretty exciting, and you'll hear more about this over the next several months. All right, so here's an overview of our educational programs that we offer. We have several competition-based fellowships and award programs, and many of these awards and fellowships are aimed at graduate students or postdocs and may be for anywhere from like $3,500 up to $8,000. And as I mentioned earlier, I'll speak more about these grants programs in a few minutes. We also offer training workshops, including our snow school, stream sensor workshop, and wharf hydro, for example. And while many of these have traditionally been in person, some were able to be offered virtually during the pandemic, and some are only offered virtually. And Julia might speak a little bit more about the trainings when I pass the virtual mic to her. We have a robust cyber seminar program series, and this has grown tremendously during the pandemic. We offer a wide range of topics on related to the water sciences. And we also have some cyber seminar series aimed at professional development for graduate students. And we have a good lineup of critical zone related cyber seminars. We of course have CUAHSI Virtual University, and we're so glad that you're a part of that this semester. And we have a hydrology guest lecture database. All right, so we have a couple of cyber seminars either starting or in the queue. So I just want to draw your attention to these. The Critical Zone Cyber Seminar Series started today at noon, and it's going to be running every Thursday until December 2nd. If you're interested in that, you can register for that. You don't have to attend every session. You can attend as many as your schedule permits. We also have a cyber seminar series starting on November 2nd on digital hydroconnectivity. And you can find more information about both of these series on our website. And I can put the details in the chat as well after I stop talking, or Julia can pop it in. And finally, I do want to note that CUAHSI has offered several cyber seminar series in partnership with AGU H3S, which is the AGU Hydrology Student Section Subcommittee. These series have been very popular, and they're aimed at providing professional development for graduate students. While we don't have a series running right now, we record all of our webinars, and they're posted on our YouTube channel, so you can check these out at your convenience. And I just show what some of the topics were for our most recent AGU H3S Cyber Seminar Series. All right, so as I mentioned earlier, we have several small grants and awards programs, which I have listed here, the ones that graduate students are eligible for. I'll talk more about Pathfinder and Hydroinformatics Innovation Fellowship in greater detail in a minute, because those call for proposals are currently open. But I do want to draw your attention to our Let's Talk About Water Challenge, which uses okay, so I want to, so I'll talk about the Let's Talk About Water Challenge just for a second. That uses film and panel discussions to promote water science education and critical thinking about water-related issues. That call for proposals will be open soon, and it's a wonderful opportunity to offer a public forum for discussion about water issues, to look out for that call for proposals to come soon. We also have our instrumentation discovery travel grants, which enable scientists to learn about instrument installation, operation, maintenance, and processing by visiting experts elsewhere. So if you're starting a new job, for example, and you're setting up a lab somewhere, but you want to learn about how somebody else is doing some sort of instrumentation, we can offer funding to let you travel to that other person's lab, learn about their instruments, and then go back and set up your own lab. And there's other examples of uses for that instrumentation discovery travel grant. That call for proposals will be out in spring of 2022. All right, so the Pathfinder Fellowship is our longest running fellowship program. The goal of the Pathfinder Fellowship is to enable a new dimension to be added to a graduate research project, such as visiting a new field site or adding some sort of interdisciplinary component or doing some sort of a comparative study. New this year, we're welcoming proposals related to the Critical Zone Collaborative Network. So if you're a critical zone scientist or someone working on a critical zone project, you can propose to visit a new critical zone site. And there's details on our website about that. So the Pathfinder Fellowship was established in 2009, so we're over 10 years old, and we funded close to 30 graduate students during this time, totaling funding amounts of over $200,000. As far as we know, and we've been trying to track this, 11 papers have been produced as a result of a Pathfinder Fellowship, and they've been cited many times. So these are well received academically and in the research community. So as I've mentioned, the call for proposals is currently open. To apply for a Pathfinder Fellowship, you would need a 2-page CV, a research statement, which describes your proposed research, a budget, and we're funding up to $5,000 per project. We would need a letter from your advisor and also a letter from the host for where you're proposing to visit. Proposals are accepted through an online platform, and you can start the proposal and complete it later if you need to. The application deadline for this fellowship is December 24th, so you have some time still, and awards will be announced hopefully by early February. On our website, you can find examples of previously funded projects and more details about the projects. I love this picture here. This is Joseph Waswa, who is a PhD student at Syracuse University. He used the Pathfinder Fellowship to take water samples in Uganda as a comparison to a domestic site. He's talked extensively about his experiences that were made possible by getting a Pathfinder Fellowship, and you can hear more about his work from our website. All right, the other call for proposals that's currently open is our Hydromatic Information Fellowship, Hydroinformatics Innovation Fellowship. And the purpose of this fellowship is to support the creation of a hydroinformatics product that is useful to the water science community and can be ideally distributed by CUAHSI. We found that our HIF awardees may need to work with our technical services staff or interface closely with them to figure out that piece, but we're happy to help you in any way that we can. This fellowship program is unique because it creates a pipeline of software products for the CUAHSI community. Our 2019 fellows, for example, developed software that provided automated quality control, provided visualizations for selected types of time series data, and performed data analysis. So pictured here is a screenshot of Scott Hemshaw's work when he was at University of Vermont. He developed a web app that was a hydrologic event analysis tool called HEDA. So this fellowship program is quite new compared to our Pathfinder Fellowship program. So far, we've supported 10 projects for a total of about $50,000. So this year, we'll consider proposals that request funding of up to $5,000. And eligible expenses for that include travel costs associated with acquiring new skills, site or reverse site visits, software or data licenses, access to cyber infrastructure, dissemination costs, or student support. The application process is similar to that of Pathfinder. And again, you would go through our proposal portal, and you can find more information, including details about previously funded projects, on our website. And lastly, I want to just draw your attention to some of our community resources. Most notably, we have a very active job board. I have a copy of a screenshot here of our job board. So if you're finishing up your degree and you're looking for a job in the water sciences, check out our job board because it's available. All right, so with that, I am finished with my section. I'm going to stop sharing and turn the mic over to Julia. Thank you.
All right, thanks, Deanna. Let me share my screen here. There we go. All right, does that look all right to you all? Okay. So hello, as Deanna mentioned, I'm Julia. I'm the Education Outreach Specialist at CUAHSI. I have my email here. Feel free to reach out if you have any questions about what I'm about to talk about. I'm just going to take a little bit of time to briefly touch on CUAHSI training workshops and then go into a little bit more detail about the National Water Center Summer Institute program. I will say before I get started that, you know, especially with the case of the Summer Institute, it's not just me behind it. Veronica is also going to be working with me on that project, and all of our CUAHSI services. You know, feel free to reach out to any of us, and we'll make sure that it gets to the right person that can answer your question. Okay, let me read it. So training workshops. CUAHSI hosts a number of training workshops throughout the year that are intended to provide training on a specific topic or skill that wouldn't be available through a single institution in and of itself. And as Deanna mentioned, these are traditionally in person, but increasingly virtual. But we hope to get back to some in-person trainings soon. Some things in general to note is that it's an opportunity to learn a skill. It's also an opportunity to grow your professional network and meet other graduate students and professionals that are interested in these topics. And also there are travel grants available for graduate students. On the slide I have while supplies last, but for many of our training workshops that require travel, there are a limited number of graduate student travel grants available on a first come first served basis. So when you're considering some of these training workshops, keep that in mind. As the year starts to wrap up here, we're working on approving the 2022 training workshop schedule. So if you look at our website now, in upcoming trainings, there's not too much, but keep an eye out for announcements as they come out through our newsletter and on our website. A couple previous trainings are listed here. The Community Wharf Hydro Modeling System. We work with the Wharf Hydro team at NCAR to put on ideally 2 workshops each year, generally in Boulder, Colorado at the NCAR offices, but the last couple of years they have been virtual. We also host our snow measurement field school each year. In January of 2020, it was hosted in New Hampshire, which is the photo that's pictured there. And it's an opportunity to learn field methodologies for measuring snow. And so we had students that are working with snow measurement for remote sensing applications that really hadn't done this kind of field work before, alongside graduate students who were about to go on a NASA SnowX campaign where they were going to be directly applying these snow measurement techniques for a broader project. So those are just a couple examples, and there's plenty of other trainings that we've hosted in the past and hope to in the future. So keep an eye out for those. The other program that I want to focus on primarily for this talk is the National Water Center Summer Innovators Program, Summer Institute. So the Summer Institute, affectionately referred to as the SI, was established in 2015, originally as a partnership with the National Weather Service and CUAHSI to engage the academic research community with the enhancement of the National Water Model. So this program's been going on for a number of years now. Regrettably, in 2020, the Summer Institute was postponed, but we were able to hold it virtually in 2021. which went as well, pretty well. But we do have every intention of hosting it in person again in 2022. And so I'm going to be speaking with that in mind. It's an intensive summer program in which graduate students convene at the National Water Center in Tuscaloosa, Alabama for 7 weeks to conduct group projects that culminate in a capstone presentation. Over 150 students have participated in the program from over 77 universities. So really students from all over the country, excuse me, have really come together to create this community of Summer Institute alumnus at this point. Theme leaders from US universities, along with staff at the National Water Center, advise on these projects throughout the summer. The National Water Model, in case you're less aware with it's a continental scale model, and it forecasts stream flow and flooding for the continental United States. The model provides stream flow for 2.7 million river reaches across the United States. And so this is a huge effort with national implications. And the Summer Institute allows students an opportunity to advance research on specific aspects of the model in ways that align with this national effort. So working at the National Water Center, which is overseen by the Office of Water Predictions, that's where the National Water Model lives for the most part. But research projects for the Summer Institute are arranged into themes, which are meant to guide the research questions that are of specific interest to the National Water Center. These themes are chosen with the expectation that these topics may have the most significant impact on moving forward the goals and the mission of the National Water Center. So as priorities of the National Water Center change each year, the themes may change slightly, but to give you an idea of some of the sorts of projects that you might see at the Summer Institute, these were the themes that were chosen for 2021. So we have coastal coupling, model process and module development and testing for the next generation National Water Model. So theme number 2 there is one that you can see very directly kind of feeds into future next steps for the future of the National Water Model. We also have a hydro-informatics theme, as well as a theme focusing on machine learning and applications of machine learning for water prediction. So the outcomes of the Summer Institute are twofold. There's the tangible outcomes, the capstone presentation at the end of the summer and the technical report, but there's also the intangible value that students have gained from the Summer Institute. I want to be sure to highlight that the Summer Institute is asking students to answer very big questions that require skills that apply to many different aspects of hydrology, which is a strength of the program. Students are not expected to have all of the skills to solve these problems on day one. That's why students are running from across the country and from differing levels of expertise. So there's a 2-week boot camp training to kick off the summer, but then the team structure allows for students to learn from one another and help one another. So in the past, there have been teams with varied levels of coding or computing experience, all to say that every student brings their strengths to the table to work on these projects. At the end of the program, each team will develop a technical report and a capstone presentation that details the work that they did that summer. Previous technical reports can be found on the CUAHSI website. The technical report for 2021 will be posted soon in case any of those themes especially jumped out at you. But all that is to say that the Summer Institute brings some of the best and brightest graduate students in water science together for a summer to work on projects alongside professionals at the National Water Center and academic institutions. It's an excellent opportunity for graduate students to not only gain a ton of excellent technical experience on kind of the inner workings of these models, but also gain a network of peers and professionals in their field. Many Summer Institute alumni have gone on to work alongside the National Water Center or with CUAHSI, but you don't have to take my word for it. I've pulled some quotes from Summer Institute alum and current CUAHSI employee, Austin Rainey, to give a little bit more context as to what it's actually like to be at the Summer Institute in Alabama for the summer. Students really have a lot of fun, but also it's a lot of work. So here's just some quotes from Austin, as well as some photos that of all the work they did. They formed friendships and opened doors for future collaboration, gain some technical experience or practice, collaborating around and completing open source reproducible projects, and gain confidence and experience through team presentations, and improve their ability to effectively communicate to others with overlapping disciplines. In addition, all of the students are staying at University of Alabama for the summer, and had the opportunity to go on a number of field trips and expeditions around that area of the country. And we hope we're able to provide that again in the summer. So some logistical information, if all this sounds interesting to you. Graduate students affiliated with US universities are eligible. Their housing as well as a stipend is provided, along with potentially an honoraria. The application period will open in November and close in January. The application includes, an application form, statement of interest, CV, transcript, and a letter of endorsement from your faculty advisor. This letter is especially important because in order to participate in the Summer Institute, you will have to kind of step away from your other graduate research. And so we want to make sure that, your faculty advisor is willing to give you up for the summer. And finally, if this is all interesting and you have other questions or would like to learn more and are attending AGU, we are going to have a meetup for the Summer Institute. You'll receive information to your email about that coming soon, or you can find us at the CUAHSI or NOAA booths. There should be folks at either of those places that'll be able to tell you more about the program. Also keep an eye out for webinars this fall and winter. That would be another opportunity to kind of learn more about the program and ask questions of program organizers and instructors. And then again, feel free to reach out at any time if you have any questions about the program or applying. And that's all from me.
Thank you, Julia. Tony, you're up.
Great. Thanks. Let me share my screen now. I think I want this one. And if we can make this full screen, that would be great. All right. Does it look all right? Great. So I was asked to give a short overview of, I'm trying to get things out of my way. A short overview of CUAHSI's software services and the technical stuff that we develop. And in doing so, it turned into an incredibly brief overview. And then I decided that it might be more worthwhile to give a high level and then dive into one application that might be most applicable to people that are attending the virtual university this year. So my name is Tony Castronova. I'm a senior research hydrologist at CUAHSI. My area of focus at CUAHSI is actually more on the cloud computing and hydrologic modeling side, but I'm very involved with the data services, which is going to be the primary focus of what we talk about today. So this is my attempt at kind of organizing a lot of the work that the things that we develop, and also some of the things that we collaborate with others on. And we are not necessarily the lead developers on all of these little pieces of software, and I'll talk about them in a little bit of detail here in a second. But one thing to point out is that this is certainly not a comprehensive, this image is not comprehensive. It's not everything that we do. So just keep that in mind, I guess. So if we look at this X and Y axis, and then the bottom, we're looking at use cases, things like data discovery on one end of the spectrum, and very applications or modeling based analysis type of activities on the opposite side of the spectrum. And then the y-axis, if we are focusing on the different types of audience that we have, maybe an educational audience at the bottom left, and then towards the top, we have more of a research focus. We have some of our older pieces of software are more established ones. On the left-hand side here, Hydro Client. I don't know if you can see my mouse here, but that's this little image over here, and an uploading service for getting your data into your observation data into that system are kind of right in the, or at least the Hydro Clients, right in the middle of education research. It's actually one of our most used pieces of software. It's a place where you can go and search for all sorts of different Earth observations across many different federal agencies, as well as research groups. So it's a pretty cool piece of software. And we're actually going through a modernization right now. We're modernizing the software behind that system. So it's something we definitely invest quite heavily in. And the uploader on the top left is definitely more on the research side of the spectrum, because that's getting your data that you're collecting into the system. But that's kind of how this figure is laid out, just to give an example. And I'm not going to go through everything that's up here, but if we look right in the center, we have this piece of software called Hydroshare, which I'm sure some of you are familiar with. This is kind of right smack in the middle of discovery and analysis, because you can kind of do a little bit of both. It's also educationally focused and research focused. It's used for educational and research applications. We are positioning it as kind of a center point of our software services. So many of the things that we see around or to the right of Hydroshare are smaller pieces of software that are independent, but work well with Hydroshare, meaning that you may be in Hydroshare and moving your data into these other systems like MATLAB for running MATLAB, or MATLAB Online for running MATLAB code in your browser, or Jupyter Hub for running Python and R code in your browser. But you also may be going to those applications directly and saving your data back into Hydroshare. We're starting to support community developed web apps. So that are written in the R programming language that use the R Shiny library, or written in Python using Streamlit library. So if this is something that interests you, please reach out to me or anyone at CUAHSI. This is something that we're really excited about. We're looking for people to use. We also have some more modeling and analysis type of applications. The Continental Domain Subsetter allows you to extract static data sets associated with the National Water Model, which Julia just spoke about, at different local and regional scales. So you can run model simulations on your own and tinker with the model, force it with different data and such, while aligning your work with the national efforts. So we're supporting a couple different versions of the National Water Model right now, and also PARFlow. But this is our overview. And, unfortunately, in 15 minutes, you can't go into much detail about any of these. And that's why I decided I'm going to focus on Hydroshare here. Some of you that are watching this and attending may already know a little bit about Hydroshare, but I'm hoping that I'll be able to highlight a few things that maybe you are new to you. So like I said, Hydroshare is kind of this central component or hub of our software ecosystem. On the left-hand side here, we have our observation services like the hydrologic information system, the HIS and the Hydro Client, the discovery interface, and all of that. And on the right, we have some more modeling specific things. Here we're looking at soil moisture for over the continental US produced by the National Water Model. And actually some of these snippets are from Jupyter notebooks that we wrote to analyze that data in the cloud. And these are actually connected to Hydroshare in that you can save your observation data you find into Hydroshare. You can also be doing some modeling activities and save your data into Hydroshare, or find model data sets in Hydroshare and launch them into things like Jupyter notebooks or MATLAB live scripts and such. Some of the key things that Hydroshare focuses on are archival, data publication, data discovery. It is a data repository, and that's what we try to keep it focused on, is managing data. And because of that, we've really spent a lot of time, and I say we very loosely, Hydroshare is a very collaborative team. Many of the developers are not employed by CUAHSI. So this is a large team effort, and quite a bit of work was put into designing a software application programming interface, or API, to allow other pieces of software, other tools to interface with Hydroshare, query data or save data, interact programmatically with Hydroshare. And that's how we're able to connect all these different smaller, sometimes purpose-built web application or tools around Hydroshare in that previous figure I showed. So some of the highlights of Hydroshare, you have data creation and preparation, or maybe a little bit of, those can actually go in different orders sometimes. We describe our data using metadata. Data publication, that's usually the end goal for an academically focused application. You want to finish your work and you want to publish it, get a digital object identifier, cite it in your paper, have your paper, cite the data set in your paper, cite the paper in your data set so people can find your work. Of course, data discovery is incredibly important. And then that data analysis wedge, it talks a little bit about OpenDAP, which I'll touch on later, but really that's the data analysis happens through these kind of third party or these external applications that are connected to Hydroshare. So if any of you are potentially interested in a Hydroinformatics Fellowship, you could even write your own piece of code that provides some sort of cool service that we connect to things like Hydroshare or the other tools that I showed on the previous page. Obviously there's plenty of public tools out there that you can just use, which is fantastic. I guess a couple other highlights that are hidden by my Zoom bar is that in the HIS, we have over 200 billion individual observations. So it's a large amount of data. We don't necessarily host all of that. We provide access to it. It's a really cool system. That thing is about 10 plus years old now. In Hydroshare, we have over 2 terabytes of community contributed data. In addition to that, we hold on to certain data sets that we feel are important, and our partners at RENCI, the Renaissance Computing Institute, feel are important, such as national water model predictions for specific hurricane events that have happened. And we'll talk about that a little bit in the future, or later in the slides. Right, so Hydroshare, kind of covered this already, but it does focus on collaboration around data, archiving your data, providing dissemination capabilities for your data, getting your work in front of other scientists, really, right? Then on the left-hand side, that's really the homepage. And I usually include this in a slide because I like the progression of the, towards the bottom of that screenshot where we start with number 1, creating data. This could happen anywhere. Usually we create it on our own computers or our local university cluster or a supercomputer, whatever we're doing. We have some sort of data. And once we have something that's worth holding on to, or we think we have something that we're nearing a final product, or we're nearing some sort of a not finalized, something that's a little more concrete, we may upload it to Hydroshare. And at that point, what we are given is a web page. And this web page has your data displayed on it. And that's about it. So in order to make it a little bit more useful, we want to describe it with metadata. So all kinds of descriptive text that tells anyone, or hopefully makes your data self-explanatory. Someone comes to their resource webpage or landing page, we call it, they can learn all about your data without actually having to download it or play with it. They should be able to read the text on the page and understand through your title and your abstract and your subject keywords what the point of this data is, what the purpose or study that was being used for, as well as spatial and temporal coverage. And there's all sorts of metadata that I'm going to touch on in a second. Then you also have the capability of sharing with colleagues. So this is typically where we talk about iterating on your data. You may share it with 2 or 3 people, and you're collaboratively adding to this data set over time. And then when you get to a kind of more finalized state, you permanently publish it and get a digital object identifier. So something that's nice here is that the digital object identifiers are free. As long as it's a finalized data set, you can request a DOI. When that DOI is issued, your data set is now immutable. And that is because if it's cited or referenced in papers, or it's being referenced in other work, we can't go ahead and start changing things behind the scenes. Like you can't just swap out the data sets. It's similar to a publication. It's basically in print, it's done. For future work that builds off of that, Hydroshare allows you to version resources, so you can have version DOIs, and it kind of bounces back between the different versions of a published resource. This is pretty common if potentially you found a mistake in your data and you wanted to correct that in case anyone came across your data set, or more likely you continue doing your research and you collect more data and you make it better, or you extend your data set one way or another, and you create a version, say 2 or version 3, version 4 of your data set. So diving a little bit deeper in what exactly Hydroshare is, there's a few different ways of visualizing data. The first one is your My Resources page. This is shown on the top left. This is your, if you're familiar with Google Drive, it's kind of a similar look and feel to it. These are the data sets that you either own or data sets that are shared with you. We have a Discover page, which is a search interface. There's nothing too fancy there. It does have all sorts of different ways, facets for filtering your data and such. And then we also have different ways of collaborating through groups or communities. And that's something that's a little bit detailed. And I encourage you, if that's something you're interested in, I encourage you to go ahead and look at our help documentation and take a deeper dive on your own. Just want to highlight a few of the key pieces of metadata that you may or may not find on a Hydroshare resource. And I think this is probably a good time to explain that Hydroshare resource is really just that data plus metadata. So I said that you upload your data set and you're given a web page. So that's basically what happens. But then when you start adding context to that web page, like a title or your authors or the spatial extent or your funding agencies, now collectively all of the data, which actually isn't even shown on the screen, but the data plus the metadata associated with it, we call that a resource. That's a Hydroshare term, a Hydroshare resource. But what we can see here is we should be able to, I guess I'm not showing the abstract, but we should get a decent idea of what this data is without actually having to see the data. I mean, the title in this particular case is very descriptive. It's LCZO stream water chemistry. I happen to know that LCZO is the Loquio CZO. It's stream discharge. I mean, we can, go ahead and look at, we even have the dates, 2016, 2017. It has a digital object identifier. So this has been published. It probably has it has its own citation down there at the bottom. You can see all the funding agencies and everything. And also one thing I guess to point out is on the top right corner, we have author identifiers. Each of these people that are listed in the author section on the top left have additional metadata on their profile page. So you can go ahead and get their ORC ID, their Google Scholar to see maybe there's a few publications that are relevant you might want to look at. ResearchGate, you can kind of get a hold of them in various ways. Email address is also there. Just want to touch on one little thing, that there's some really cool data sets that exist in Hydroshare that are worth taking a look at. And like I mentioned before, there's some data sets around hurricane events. The Renaissance Computing Institute is actually holding on to large chunks of raw national water model predictions and forecasts for these events, but there's also other efforts. And in this case, we have a Hurricane Harvey collection and Hurricane Maria, which were hurricanes that hit the US a few years ago. The Hurricane Harvey, we have all sorts of different data sets from different federal agencies like FEMA and NOAA and the USGS, in addition to other analysis and data sets and analysis codes and stuff that were created by researchers, all collected into one space. So we can go ahead and take a look at that data and it's just a grouping. It's basically a folder of all sorts of Hurricane Harvey data. The same thing with Hurricane Maria, except this is more health driven about the living conditions in the post Puerto Rico after Hurricane Maria. And now this gets into some other really interesting topics, such as discoverable and shareable data sets as opposed to public and published. A discoverable data set is, which most of these on the right-hand side are, you can go there and read all about the metadata, but you actually can't access the data files. This is because the data files may contain somewhat sensitive data or information. So if you are doing a study or have a study in mind that may have some sensitive data, Hydroshare still may be an acceptable place for you to put your findings. It's not, we don't align with, like, we're not a HIPAA compliant or HIPAA aligned service. So if it is very, very sensitive, Hydroshare may not be the right place for your data. So why might you also want to use this system other than publishing your data? And what I'll say to that is content aggregations. So this is why I'm hoping maybe I'm telling someone on this call something they haven't seen before, or someone watching this video. One of the really cool things that you can do in Hydroshare is auto-populate metadata on your resource landing page. So there was all sorts of metadata like spatial and temporal extent. You can go ahead and manually type that in, but depending on the type of file you upload or set of files you upload, such as a shape file, when you drag it and drop it onto that page, Hydroshare gets to work in reading that metadata and ripping information out of those files. And it creates something called an aggregation, right? And I have these little animations here, which I'll just let run. When that happens, we have all sorts of different data. Metadata gets pulled out of the resources and populates different parts of the page. And there's so much other information. So we can see in the top, there's a polygon with 3 features. We have a spatial reference system, an extent, all that kind of great stuff in that file. When we drag and drop a netcdf file, it's interpreted as a multi-dimensional data type, and something similar happens, except now we have this just absolutely this ton of information. All the variables and everything are described in here, but that's not all. So that's really nice and great. But what really makes this cool is that this will help us interface with other applications. So in the beginning of the presentation, I showed all those different tools and services we're developing. Well, how might this help us interface with other tools and services? Well, I created a resource recently where I uploaded some shape files. I have a river, an NHD, a clip of the NHD plus reaches, and a watershed. And I've uploaded that to Hydroshare, and it turned them into geographic feature aggregations. And that's great. But now it also registers them in a Geodatabase. And that is significant because once your data is registered in the Geodatabase, you're given web service endpoints. You're actually given web map service and web feature service, which are OGC standards for communicating geographic data over the web. Now, this is incredibly cool because I can actually just go ahead and grab that URL, go into Arc Online, which is shown in the top left corner, drop those URLs in and start visualizing the data and symbolize it and do whatever. And that's a very, very, low level or basic example of what you can do, because you can also write your own code or whatever. And you effectively have web hosting of your data because we're giving you web mapping and feature service endpoints. And that's really cool. So I call this like out of the box value that you're just given. It's pretty cool. So with a netcdf file, it's very similar. You upload that netcdf file, we rip out all that metadata, populate it on the web page or the resource landing page, but then we also register it in a threads catalog. So a threads catalog is a way, it's a web interface for, or a service, I guess, for providing API endpoints to large netcdf files or multi-dimensional files. So it's not just netcdf, but others as well. So we actually register in that threads catalog, and then we give you this threads data service URL down here at the bottom. And what that'll do is bring up, it'll help you get to a page that looks kind of like this one on the top right. And if you've ever used threads, this might be exciting to you. If you haven't used threads, you might want to take a closer look at this on your own. But this is a very crude web interface for selecting data or components of large files and downloading them, working with them. And that's all nice and great. But the real power is being able to use this threads URL programmatically. So in Python, you might use something like the Xarray library and load a data set and then extract small chunks of it. So if you were to upload a multi-gigabyte data set to Hydroshare, you're providing access to that data at anywhere from the full file all the way down to like individual bytes of the file. So it's actually really powerful there as well. So that's just a quick, I'm trying to be really brief, give you a high level overview of everything that's going on, but this is one way that Hydroshare serves as that central hub for other applications. And we're continuing to develop these connections with third-party apps. One of the ones that I work quite a bit on is the the Jupyter Hub interface. So if we were to take this resource and launch in a Jupyter Hub, or we just launch a Jupyter Hub instance, we can grab these URLs and download the data or download pieces of the data and do our analysis and not actually have to, like the threads, for instance, not have to download all that data. So with that, I'm going to conclude. And what I would like to mention is that if you have any questions on these, the Hydroshare stuff I spoke about today, or more importantly, all the stuff I did not talk about, feel free to reach out to me directly, or even if you feel comfortable with that, help@CUAHSI.org is a fantastic way to reach out to us. We have a few staff members that keep an eye on that and route the messages to the correct person at CUAHSI. So I will conclude there. Thank you.